Okay, thank you. Good morning for our participants today and also honorable speaker, Mr. Nambo. Good morning. Before I officially begin this course today, I would like to say sorry for the trouble this morning since the unstable connector and also the Zoom error. We have to delay our meeting today for maybe 20 minutes. Yeah, so we are very sorry for that. And today, this is our third meeting, and we will have a speaker, Mr. Professor Hidetaka Nambo from Kanazawa University, and also two speakers from the student of Kanazawa University. And then before we go to our speaker, today I am here with the leader of the man behind the scene, yeah, Mr. Wiga Maulana Bahiyahaki. Good morning, Mr.
Yeah, good morning.
How's your feeling today?
I'm fine.
Fine. Okay. Today, Mr. Wiga will accompany me to give or to held this meeting, to control this meeting. Okay. And then, without any further delay, I would like to invite Mr. Professor Hidetaka Nambo. He is a head of Artificial Intelligence Laboratory, Electrical Engineering and Computer Science School, Kanazawa University. And then, good morning, Mr. Nambo. Yeah, okay, Prof. Nambo, please wait for a moment. Our technicians have set you as the host. Okay, sudah? Yeah.
This field, they think computer will realize the intelligent as well as human being. So it is said that this college is
Ya,
start
gimana?
of AI field. After that,
Surat
any
keterangan.
AI researcher engaged
Yeah,
the AI researches, and many applications are
surat keterangan.
developed
Yeah,
and utilized.
yeah.
However, from the start of AI and to now, there are many booms and winters are conducted.
Oh, jam berapa
So
ini?
I mean,
Ya,
the boom
paling pas
is
istirahat
the
nanti.
golden years
Kenapa enggak
for
umi
AI.
aja
Many
sekalian pas
researchers
pulang?
conduct AI researches, and many monies
Sampai jam berapa nunggunya?
given to the AI
Tapi
researchers. So,
acaranya sampai jam
but
11,
winter
setengah 12.
is the opposite situation. These researches of AI are quitted, and fund had been decreased. So researchers have stopped to participate to the field.
Iya.
So
Ya ini, Abi lagi
generally, there are maybe 2 or 3 booms from start to now, and 2 winters. So let's see the each booms and winters. So first boom and winter occurred 1950s to 1970s, and this winter is occurred 70s to 80s. In the first boom, this is after that the AI start of AI 1956. So many application has developed. In this era, the reasoning and search is the main method of AI. So to apply the search or reasoning, the problem is represented in, for example, network style. For example, tree structure or some other related structures. So in the structure, to find the answer, we should search in the network, in the structure. But after this research, many researchers has realized that there is a limitation. For small problem, we say that is a toy problem, can be solved by AI technologies, AI techniques. But the big problem, in other words, real problem, cannot solved by AI because the size is very big. You know, the computers, for example, memory size or processor speed, the resource of computer is very cheap in this era. So a big problem cannot be solved by AI techniques. That is one of the limitation. Or there is a many probability in the real problem. For example, when you want to buy something, so you may go to the market, but on the way to market, you may be, for example, you may be accident by the traffic accident, or some thieves steal your money to your from your pockets. So many probability is considerable. But in the AI field, AI technology, the computer resource is limited. So we can only consider the small probabilities. That is the problem to consider the real problem. That is a frame problem. We say frame problem. So there are, of course, another problems. There are another problems. But anyway, we realized AI is not perfect. Firstly, we is expected to AI computer can solve any problem, but in this era, we realized AI is not perfect. So AI researches, number of AI researches are decreasing, and I just say in previous slide, many researchers quitted research, funds is decreased, and so on. That is the first winter of AI. But in the second book, in 1980s, the AI is reboomed in the specific field. We realized AI is not perfect, but the field is limited. For example, in medical field, for example, that is actually it's difficult, but limited area, AI works well. So if the knowledge of expert doctor, for example, doctor, can be extracted and implemented into the computer can act as doctors. So that is the expert system. This is a rule-based system. Rule is the extracted from expert, and rules are applied to the problem and solve the problem. But it's not all field focus. It's just focus on specific field, medical or some specific engineering field or something. And in this era, the neural network is revived. Actually, this concept of neural network is proposed in maybe 1960s, but at that era, this method is not so applicated. But in this era, the neural network is revived. So many applications are developed and utilized. For example, maybe only in Japan, the neural network called Neuro. Japanese people like to shorten the word. So Neuro is implemented in the usual electric machines. For example, refrigerator or washing machines and so on. So that is a revival of neural network. But after that, the boom is gone. Boom has gone because I think these AIs are specified in the specific field. So it is a gap of our expectation and AI's capability. That is one of the reasons of the boom has gone. Or these are, I said these techniques are utilized in some field, but the field is limited. In other words, AI can be utilized in some field, but in another field, AI cannot be applied. So this is a limitation or new limitation of AI. And maybe cost is also problem. So this boom also gone in late 1980s to 1990s. But boom has gone. Many researchers keep researches in many fields. That is I think, interval of AI. So in this era, AI is applied into many fields, but it is not called AI. Various names was used to represent their researches. So in this era, for example, the basis of the new AI technology, I say the recent AI technologies are developed: data mining, machine learning, the advanced neural networks, and so on. For example, in this era, there are many applications. One of them is a Deep Blue, or 20 years ago. It's a chess program. This program beats the chess champion, world champion. In this system, in this program, data mining technology is applied. And in 1990 and 1999, I'm afraid you know this robot. This is Aibo. The pet robot by Sony is on sale. This robot has many functions. For example, this robot has camera here, maybe here. And using this camera, this robot can trace the ball red ball. So from using this camera and computer vision techniques, this eyeball detect the ball and follow or trace the balls. This is one of the new AI technology. And that is before this one, 1995, Google has founded. They provide us the web retrieval system. And I think in this system, the very big data, websites, all websites data are handled, and they search the good result of retrieval. In this era, there are many web retrieval systems established. For example, InfoSeek or AltaVista and so on. Maybe young people that don't know the name, but old one know the retrieval site. But Google is the very good result comparing the other retrieval system. So Google becomes the de facto of the web retrieval system. Well, of course, there are many another applications or systems developed and utilized in the practical system. So after that, this is now we are in the third boom of AI. In this era, it is said that it starts 2010s. The techniques are deep learning or big data. Actually, the basis of deep learning, is developed in 2006. It's an autoencoder. I will describe it later, but this is a feature extraction method. Feature is very important in deep learning or machine learning. So this method is very, I think it's a very drastic method to extract the feature. And generally, it is set the start of deep learning. In 2012, AlexNet, that is one of the convolutional neural network, is marked great result in the image detection or image recognition contest, ILS-VRC. I mean, great result is comparing the previous year's results, the big leap is marked. Accuracy is greatly improved by this method. And the same year, the Google announced the method to recognize the image of a cat. That is also application of deep learning methods. So this year is the start of deep learning and the beginning of third AI boom. Nowadays, there are many methods, many structures of networks in deep learning, but in the start of deep learning, I think that convolutional neural network is fastly spread by other deep learning methods. So many applications are developed utilizing CNN. Okay, so these are the history of AI. And the next slide, this slide, shows the change of AI method. I think this is related to the AI history. So at the first stage of AI method, I think it is not AI, non-AI. In this stage, we use computer for the routine or manually used. I mean, for example, if you use Excel, input the numbers by yourself or from the file and make the calculation or equations and, for example, summarize the data manually, or you make some macros. Macro means a routine. So in this stage, no AI techniques are introduced. And the next stage, in this stage, I think the rule is utilized. Making some rules, for example, from expert, make some rules and utilize the rules for problems, matching the data and derive the result or conclusion. So in this era, the AI is based on rules. But these rules, how to make rules? Rules will be made by human because computer cannot extract rules. So we, for example, we make interview to expert one and we consider the rule. The data is interview result from expert and make rules. It's very taskful. And for example, this is one of the system using rule-based system, expert system. I said in the previous history, maybe second boom, this system is utilized. And the next stage, machine learning is utilized. In the machine learning, we can get rules from data. And the system based on the rules learned by machine learning techniques. So the rule in this stage, rule is made by human, but rule will be learned here automatically from data. So the task of human is reduced. But we should specify the features. Feature means what factors we or computer machine learning system focus on the data, in the data. So these features should be specified by human. It's a human's task. So in this era, we should make rules. But in this stage, we should make features. So task is changed. And the next stage, deep learning. It is based on the rules or patterns extracted from data. Rule or pattern is same as pattern and is the same as rules. So in this stage, features are automatically extracted. So it is changed. In this stage, I missed. Human should be prepared only data. We need data, much of data. So from, for example, from this stage to this stage, the task of human is changed and reduced. So this is, I think this is one of the reasons of AI is spreading now. Human task is reduced, so many people can introduce AI techniques to their works or their problems. Okay, so this machine learning and deep learning is, I think, very similar. The border is very ambiguous. So I would like to explain about the difference of machine learning and deep learning. So in previous slide, I have said that in the machine learning, we should consider feature for learning. Feature is what factor we focus on. And deep learning, on the other hand, we don't need to consider features. Ideally, actually, it's ideal, but features automatically extracted from data. This is a big difference. So let's see the example of machine learning and deep learning. So, for example, if you want to distinguish cat and dog by neural network, this is one of the AI techniques. I think the last week, machine learning is explained and deep neural network also. So to make the classifier cat and dog, we make the neural network like this. The input layer and output layer. This is dog or cat, and some hidden layer. So in this case, what is the input to the input layer? So in machine learning, using neural network or another machine learning techniques, we should consider the features. What factor will distinguish the cat or dog? For example, shape of nose of dogs and cats are different. So shape is one of the factors of cat or dog, distinguish cat or dog. Or ears, cat has a triangle ears, and dog also big ears, and so on. Size of mouth, I think dog is has a big mouth. Or this is depend on the kind of dog or cat, but weight or height or length, I mean, is a different cat or dogs. So there are many factors, but we find the good factors, good combination of factors, and calculate from, for example, this image to the shape of ears or something by image processing. That is a very complex task because there are many factors. So we should check many of combinations of factors, which is the best or not. But in deep learning, features automatically extracted. The example of feature extraction in deep learning is represented by autoencoder. This is a technique to extract a feature in the early stage of deep learning, used in early stage of deep learning. This is a special neural network. Please see this figure. This is a network, and here is an input layer, and here is an output layer. For input data, the pixel data, raw pixel data is inputted, and output layer should be trained. The same picture is reproduced. I mean, if this picture is inputted, same picture will be outputted. This network is trained to reproduce the same data. And if this network is completely trained, I mean, reproduction will be perfect. In such case, it can be said that this picture is represented by two factors because this picture is compressed only to nodes, to values. And using these two values, the original picture can be produced. So this is an important factor, important feature to represent this picture. So these are features of a cat, represent a cat image. So utilizing this concept, deep learning will extract features from data automatically. So this concept, feature extraction, is a big breakthrough of deep learning. I just said in machine learning, a lot of effort of feature extraction or selection was required to get the good result. But in deep learning, this task is reduced. Actually, we should prepare the good data and massive data more than the machine learning. But the difficult task feature extraction or selection is reduced. It's very big breakthrough. For example, this is my experience in my old research. I want to make the classification model, classification problem, want to solve classification problem. So in the previous method, we consider many features using fast Fourier transform or some statistical method and so on. And I made the great effort to select the features. And using the decision tree techniques, this is one of the machine learning method. We got the accuracy is 84 points. Or using another method, this is same. Multi-layer neural network. This is a not good result. It is 58% points accuracy. But using the deep learning techniques, it is no need to consider no effort to select features, just using the raw data. And it's marked 86 points. So I saw this result. I'm very disappointed, and because my effort was not no required effort, because the same or more good result can be obtained just using raw data. The same things is occurred in many fields. For example, in the shogi, Japanese chess, many researcher or developer makes the shogi program to compete with human or other programs, and they in previous method they make many features. For example, the location of units or number of units or the region of the stage. There are how many units or what kind of units are there, or the king is checkmated or not. There are many features. However, using the deep learning techniques, I think just using the location of units, they can make more strong program than before. That is, they say their effort to consider the features is not required now. So they are disappointed or they are pleased. I don't know, but it's a very good big breakthrough. So the deep learning nowadays are utilized in many fields. For example, audio and image recognition, face detection or fingerprint and so on. And the audio recognition, speech recognition, and recognized speech are processed and natural language processing techniques, and for example, Siri or Alexa, Google makes the AI speakers, or translation, for example, Japanese to Indonesian. It is the accuracy is greatly improved recently because they utilize the deep learning techniques or some other fields. There are many deep learning utilities, applications. But the requirements are a little bit different from before, because the data number of data needed to required to deep learning becomes increased, and computation time. This is a very big problem. Computation time is increased, so we should prepare the GPU to conduct deep learning. It's a must. GPU is must. But nowadays there are many new techniques. For example, number of data is reduced, but accuracy is improved, or computation time is reduced. So GPU is not required. The general CPU, only general CPU, the deep learning can be conducted. But these techniques are still on paper or laboratories. I don't know these techniques are utilized in practical field or not. But in future, I think these problems will be solved. So let's see the one of the famous method of deep learning. That is a convolutional neural network, CNN. So this method, CNN, is good for the image recognition or classification, but not only image recognition, but in other field, audio processing, recognition, and so on, can be utilized. And for the image recognition, I think that is the first utility of CNN. And CNN is based on based on the human's visual system. In our human system, we have some cells in our brain, and which react some patterns, and the reacted cells are aggregated, and we recognize some shapes. So this concept is modeled to the network. That is a CNN. So this is I think this is a primitive structure of CNN. The point is there is a convolution layer and pooling layer. This is a full connection, and output is, I think this is same as neural networks. So what will be done in convolution layer and pooling layer? In the convolution layer, the filter is multiplied to the original data and detect the patterns represented by filter. This figure shows the example of filter and data. So this is a filter. It is represented by binary digits, but if this data is represented in image, we can see there is this direction of slanted patterns. So this filter detects the slanted pattern from this data, from input, by multiplying the filter and input. This is a convolution. So what in the detail, this filter pattern is multiplied here, after that here, here. So cover all image, all data. So this is more details of convolution. So from this area, this value is obtained, or another area, another value is obtained. So this value means that in this area, how much the pattern means, in this case, this pattern, slanted pattern, is matched or not. I mean, this 25 is larger than 18. So this, comparing this area and this area is strongly appeared the pattern than this area. So to all area, convolution is calculated, and the pattern, how much the pattern is, how much strong in each area is calculated. In this example, filter is given like this, but actually filter pattern is adjusted in the training process. I mean, in the training process, the good pattern also adjusted, found it and adjusted. And after that, after the convolution, pooling is conducted. In the pooling layer, the downsample is conducted, applied to the data. So downsampling means make smallen the image or the input data. For example, this figure shows the pooling to half size. So half size, to shrink the half size, the 2x2 filter means a pooling filter is applied to the image. In this case, max pooling is applied, so we choose the max values of each area. And the result is the half size of original input data. So this convolution and pooling is conducted to extract the feature. Feature means characteristics of images. So usually, this is I said primitive one. So actual one or another variants, convolution and pooling are iterated multiple times. For example, AlexNet, I explained in the previous slide. It has 5 convolution layers and 3 pooling layers. Or this is a similar primitive one, DNet. This has a 2 set of convolution and pooling layers. I think this network CNN is very famous in tutorial with MNIST data. So I will explain about after this slide. Or there are another variants. There are many variants of CNN. To obtain the good result, more complex, not only convolution and pooling, or another structure they have are developed and utilized in many fields. So, しまった逆だ。this slide shows the MNIST data. This is a handwritten digit data using the LINET. You can see some pictures of numbers, of digits, 0 to 9. There are many varieties because many persons write different digits. So we want to distinguish the number of digits by CNN. So this is a LINET for MNIST to classify the number of digits. So there is two pairs of convolution and pooling. After that, full connection and output layer. So in this case, input is so I forget. Maybe 24 by 24 pixel data. Here, maybe numbers, digit is written. 25 だったかな. So this, I said, this is a filter for to detect the pattern. So after the training, the filter will be like this. It is very hard to say from something from this result, but for example, we can see this filter will detect the slanted, left down slanted patterns, or this filter maybe right down patterns, and so on. It's difficult to say, but adjusting the filter, these filters will extract some features, some characteristics from handwritten digit. For example, 5 consists the horizontal line and some slanted line and round one. Maybe these are consist like this digit. So we want to detect this pattern, and aggregate. That is conducted in this network. And this is the last one, how to implement the CNN or other deep learning methods. I think it's difficult to make all things on the network. So it's better to use a frameworks. For example, TensorFlow, Keras, PyTorch, and so on. Now I'm mainly use Keras, but our students they say they are using PyTorch, other frameworks. And the language is usually Python, because many frameworks, of course, these frameworks are provided to this language. So I think in my laboratory, I don't know use another language. The student using another language. Anyway, I think I'd like to explain about the implementation in the next week. So, okay, so this is the final one. I would like to summarize my talk. I talked about the history of AI in the aspect of the changing of AI technology. And I have explained about the difference of machine learning and deep learning. That is feature extraction is big difference. And after that, one of the famous method in deep learning, CNN, is explained. The characteristics of this network is convolution and pooling. That is based on our visual systems. And this is last one is a continuous topic to next week, how to implement the deep learning methods. Python and frameworks will be utilized for this implementation. Okay, so this is the end of my talk. Thank you for your attention. Thank you very much. So now Q&A time. Okay. Chat.
Gak ada. Lo ngebug.
Okay.
Okay, and I would also like to greet Mr. Imam Tahyudin who have joined us here. Actually, I'm sorry, I forgot that I have to greet Mr. Imam Tahyudin.
Enggak.
Yeah, would you like to give us maybe some comment, maybe, or your speech, your
Siapa
greeting
gua?
speech, Mr. Imam,
Enggak, yang nyanyi pasti.
dealing with
Nggak
the
tahu.
lecture given
Ada
by
yang nyanyi.
Mr. Nambo?
Tadi ada yang nyanyi kok. Kali lo bukan di tim dari tadi gua.
Yeah, okay.
Yang nyanyi.
And
Bro.
still waiting
Bro,
for the question
please.
delivered by the
Sumpah.
participants. We would like to remind you, the participants, to fill the form of attending list. You may check on a group chat. Here we have shared the link to make the your attendance.
Okay.
Okay, ya silakan.
Okay, thank you so much to
you.
Professor Hidekanambo for your presentation. I think the topics about the what is it, deep learning fundamental is important for our students, and I wish the student can
I wish.
study more about the deep learning, because the deep learning methods is the actual, or the what is it, the robust methods in data science. And then maybe to all of the audience, especially from student in Universitas Amikom Purwokerto, if you want to ask more, want to give questions, maybe please you write on comments. And I think this is the important or the interesting event that you can ask directly to Professor Hidekanambo. Yes, I think that's all. Thank you so much. Arigatou gozaimasu.
Terima
Arigatou
kasih.
gozaimasu. Thank you, Mr. Imam, for your speech. And then we have tadi Hendy Pradana ya. Or who else?
Eradika.
Eradika Reza, who want to deliver some question maybe, please? Okay. So,
Aku dulu mungkin.
maybe Mr. Wiga, you want to deliver some question?
Yeah, yeah. I have
Yes, please.
some question, but the first, this is the question for you, Prof. Nambo. Yeah. Yeah. We see that everyone is using AI today, but how about the development of AI in the future?
In the future.
Yeah.
Okay, so this is my opinion, but I think AI will be gone because in the front of anything, the word of AI is not appeared, but AI is worked in the hidden place. So many users don't realize the AI is working or not, but system is very intelligent. So in many fields, AI technology will applied, but user don't care it's AI or not. That is the feature of AI. It's my opinion. Thank you.
Okay.
Yeah, sorry. Interesting, yeah, since and Prof. Nambo,
Yes.
maybe I want to deliver one question. This is
Okay.
dealing with my concern because I'm coming from the field of linguistics, that is translation. So that I want to ask you about how about the natural language processing, yeah? On your slide, I see that from natural language processing, we can process the translation. So I would ask about, can we make a better result for the translation? Or maybe the natural language processing can process the input or the data that we input into the program as natural as we speak. Or maybe we need to make some changes, or we need to make certain formats so that the program can give the better result of the when they translate our language.
You mean the translation accuracy
Yeah, that's
will
about accuracy,
improve or not?
maybe.
Accuracy? I think the accuracy will improve because new technology, new method of deep learning are introduced to such field. And for example, Google Translation, previously it is not good, but recently the accuracy or quality has improved. Or another translation service, for example, DeepL, is opened for we can use the new systems. So I think this is one of the hot field of AI and improve in future. It is my it is answer.
Yeah, okay. Thank you,
Okay.
Prof. Nambo,
Sorry.
for your answer. And then, still one question. On Zoom, we haven't been displayed here.
Chat on chat.
No.
Is it on chat? Data.
Yeah.
I found
Okay.
one.
From Hasri Akbar, in your opinion, what's your favorite framework?
Yeah. I mainly use the Keras. That is a wrapper of TensorFlow, because I started the learning of deep learning with TensorFlow, but
Deep
it is a
learning.
little bit difficult. But Keras is easy to use. But recently, there are many other good frameworks developed and opened. So it is difficult to recommend which one is better or not. But I like Keras still Keras.
Okay, thank you. And then another question maybe. Okay, dealing with deep learning and machine learning, Prof. Nambo. Can they collaborate to in a program to work the program maybe in the future?
Collaboration of
Collaboration of
and
machine
deep
learning
learning.
Collaboration.
and deep learning.
Yeah, I think the yes, collaboration is available, but I think we should uh, apply the machine learning or deep learning for the field, suitable field. For example, machine learning is suited for some field, and deep learning is suited for another field. So we should change the method depend on the subject, because the
Okay.
deep learning cost is very high. Cost means resource, computer resources. Machine learning is the less than deep learning. So depend on the cost or resources and so data and so on, we should change the method.
Yeah, okay.
Okay.
Thank you for your answer, Prof. Nambo. And then
Yeah, maybe I have one question, Ken.
once more, please.
Yeah. Can CNN process the raw data? Raw data.
Raw data.
Yeah.
Yes. For example, usually in the image processing, the pixel data, that is the raw data, is applied to the network. And for signal processing, the raw data just measured, for example, volume, or I'm not sure in the audio signal, but the raw data is applied to the different CNN. Okay.
Okay, thank you.
Yeah, okay.
And the last maybe, how to improve performance of deep learning?
That's a difficult problem. If the method is fixed, I think the accuracy or quality is depend on the data. Good
Okay.
data should be prepared.
Depend on data.
Yes.
Yeah. Okay, thank you.
Thank
Okay.
you.
Enough, Mr. Viga. Okay, so thank you, Prof. Nambo. This is the end of our session for question and answer. And then the next session, we will hear or listen the speech or speaker from Kanazawa University students.
Yes. Okay.
Today we have two two students from Kanazawa University who want to deliver their project result or their work about artificial intelligence. Okay, so let us set them to be the hosts so that they can.
So first one.
The first one is
Mr. Nakata. どなたまになってます。中田、下の名前。
Nakata, okay.
言ったね。
Okay, we have set for Mr. Nakata. So, Mr. Nakata, are you ready for delivering your presentation?
The detection model for industrial products using deep learning. Okay.
Yes. I will give a presentation titled Consideration of Anomaly Detection Model for Industrial Products Using Deep Learning by Shunta Nakata, Kanazawa University. Anomaly detection in industrial product is mostly done by human eye, but it has several problems. For example, labor costs arise, and the criteria for judging depends on each person. So when it comes to automating the process using machine learning and deep learning, there are certain conditions. Since most industrial products are normal, it is difficult to obtain anomaly products, so supervised learning is difficult to achieve. That is why I decided to use unsupervised deep learning with autoencoder. Autoencoder is roughly divided into encoder and decoder. Encoder compresses features of original data. Decoder reconstructs images from the compressed features to be closer to the original images. As shown in the figure on the left of this slide, reconstructed images are close to the original image by the autoencoder, trained on all images of 110 digits. In construct, as shown in the figure on the right of this slide, the autoencoder trained only images of 110 digit of 1 can construct other digit 1, but cannot reconstruct digit 4 clearly. When the digit 1s are considered to be normal and digit 4s to be anomaly, we can use this method for anomaly detection by comparing the difference between the anomaly image and its reconstructed image. The model I used this time is BAE. It is autoencoder with the idea of probability distribution. BAE is a normal distribution generative model optimized by deep learning. By learning various types of handwriting digit folds, this model can be used to reconstruct expressive digit folds. Here, I would like to introduce the paper, Anomaly Manufacturing Product Detection using Unregularized Anomaly Score on Deep Generative Models. When detecting anomalies by cropping parts of a complex image, the distribution of the loss function is different between the parts appearing frequently and the parts appearing occasionally. The situation is shown. The problem is the likelihood of normal in occasionally appearing class and anomaly in frequently appearing class is same. So it makes it difficult to set a threshold because complex features are judged as anomaly, even though the features are actually normal. According to the paper, the solution is using the unregularized anomaly score. As written in the right In the lower right corner, the loss function can be divided into three main categories. DVAE is related to frequency, and AVAE is related to complexity. By removing the regularization terms DVAE and AVAE and using only unregularized term MVAE as the anomaly score, we can remove frequency and complexity, so we can be distinguished by same threshold. Using the method in the paper, I applied the patched image evaluation to our dataset as experiment 1. Used images are provided by a collaborating company. I used 50,000 normal images as training data and 8,077 normal images and 1,796 anomaly images as test data. Defects are generally very small in relation to the whole image, and they occur in the outer part. In this experiment, instead of using the whole images, I used 300,000 patches. I randomly selected one image out of 50,000 normal images and repeat process of creating 128 square pixel patches with random coordinates and use it as training data. When calculating anomaly score, I selected one of the test images in order and calculated anomaly score of upper left patch, then change focusing on calculating patch by moving 64 pixels and repeat process until bottom right most patch. In this calculation, I gained 49 patch score per one whole image. Anomaly score is maximum of these scores. In this experiment, I compared using types of anomaly scores, conventional score, unregularized score, and maximum difference 1 pixel score. The maximum difference 1 pixel score is maximum absolute value of this difference for all pixels. In the next, I introduce index for evaluation. The first index is sensitivity. It is a percentage of actually normal products predicted to be anomaly by discriminator. The second is specificity. It is a percentage of actual normal products predicted to be normal by discriminator. The score histogram shows the distribution of frequency belonging to anomaly score value of each image. It is ideal to be able to completely separate the normal and anomaly classes. A threshold is determined at the point where sensitivity plus specificity are maximized. ROC curve is a curve with sensitivity on the vertical axis and 1 minus specificity on the horizontal axis. The closer ROC curve is to the upper left, the better the performance of the discriminator. This is the first result. They are anomaly heat maps at each score. The darker the color blue, the higher anomaly score is. And we can see VAE with maximum difference from pixel score is more able to discriminate anomaly. They are score histograms and ROC curves. The table shows the sensitivity, specificity, AUC, and detection time. VAE with maximum difference 1 pixel score achieved the best accuracy. The problem is these models are not practical because it takes a long time to detect anomalies. So I would improve it. In the next experiment, I used non-patched images. From previous experiment, some conditions have changed. In the next experiment, I used original images for training, and I tried 3 training laws to check effectiveness and regularized term. Anomaly score is fixed at maximum difference score. The main purpose of this experiment is to speed up detection time. In the previous experiment, scores of one image are calculated by 49 patch scores, so detection time was longer. It has been improved in this experiment. I will talk about result of this experiment from this slide. They are examples of an image of absolute difference between the reconstructed image and original image. The upper images are normal products, and the lower images are anomaly products. Normal areas are black, and anomaly areas are white. BAE with unregularized training loss is able to detect anomaly more clearly than BAEs with conventional training loss. There are score histograms and ROC curve using BAE with each training loss. BAE with unregularized training loss can separate classes between normal and anomaly more clearly than BAE with conventional training loss. Detection time is also faster than previous method. These tables are summary of two experiments. From cycle 1 and 2, we can confirm the unregularized score is effective as claimed in the paper. It is better accuracy and shorter detection time in the non-patched image evaluation. The BAE trained using unregularized training loss gives the best accuracy. I believe that using the maximum difference 1 pixel score for dataset is effective, but I don't know if it would be effective for other datasets. Patched image evaluation may be valid for other datasets, so I will evaluate on other datasets. That's it. Thank you for listening.
Thank you, Mr. Nakata.
Yeah, thank you for Mr. Nakataka for delivering your work. And then, is there any question? Maybe participants, you may deliver your question on a chat box or click the bottom of raise hand. Oh ya, partisipan dari Indonesia mungkin boleh juga memberikan pertanyaan dengan menggunakan bahasa Indonesia. Nanti kami coba bantu untuk menerjemahkannya sehingga bisa tersampaikan kepada Mr. Nakata. Silahkan. Or maybe Mr. Wiga, you want to deliver some question dealing with the work of Mr. Nakata? Yeah, because your work is actually so sophisticated and you give the presentation in details, Mr. Nakata. So we just maybe we just express it by clap, clap, clap. That's so wonderful and wow. Okay, maybe while waiting for question for Mr. Nakata, we may go to the next presenter, Prof. Nambo. Who's the next?
Okay, so let's move on to the next one. So next is presented by Ms. Haneda.
Yeah.
Amy Haneda. Ms. Amy Haneda. Sorry. Next one is Ms. Amy Haneda. 今、中田君の放送分戻した。Okay, so now she will starting screen sharing and
Yeah. So.
Okay. So please start sharing.
Oh yeah, Omi Haneda.
Oh, yeah. Yes. Her title is a study on the detection of pathologic tuberous using UNet. Okay, so start the slideshow. はい。
Now, I'd like to give a presentation of my research using AI technology. The title is A Study on the Detection of Pathologic Tubules Using UNet. UNet is a model of deep learning for image recognition technology. The tubules is a part of the kidney tissue. In this research, I'm using AI to analyze medical images. First, as a background of this study, I explain the kidney pathology. Kidney disease is first determined by the scores of blood test and urine test. If the scores are not normal, it means that the patient has something wrong with your kidney. But only actually, there are two types of tubules. One is the proximal tubule, and the other is distal tubule. The doctor uses this image to make an accurate diagnosis. In recent years, AI technology has also been used for kidney biopsy images. Mostly, it is used to recognize glomeruli, but currently it has also been used to identify glomerular lesions and assess the degree of interstitial fibrosis. However, the technology for detecting pathologic tubules and identifying their types is has been more difficult. So even for doctors, diagnosing tubules is more difficult than diagnosing glomeruli. The goal of my research is to detect pathologic tubules and to identify their types by using AI technology. The technology is semantic segmentation. Next, I'm talking about semantic segmentation. As shown in the image below, the technology is extracting the shape of each object. The input photo is labeled pixel by pixel to extract the shape of the object. Recently, it has been used for automated driving and medical images. There are several models for semantic segmentation. In this research, I chose UNet because it developed for medical image segmentation. There are two main features of UNet. The first is encoder-decoder structure. In the encoder, convolution is performed, and in the decoder, deconvolution is performed. The second feature is skip connection. The skip connection is the process of keeping the feature map in the encoder and adding it to the corresponding layers of the decoder. By performing convolution, we can find out what the object is. On the other hand, skip connection tells us where the object is. The dataset we used were 229 images of kidney biopsies. We prepared the original images of the kidney biopsy and also prepared the corresponding annotated ground truth. The left is kidney biopsy image and the right is annotation image. Annotation were done using the label in this table. We divided them into glomeruli, two types of healthy tubules, arteries, and three types of pathologic tubules. The rest of the areas are labeled as an interstitium. The three types of tubules are tubulitis and degenerated tubule and atrophic tubule. The variation index is represented by the percentage of pixel-by-pixel agreement between the output and the ground truth. The confusion matrix is also used to show the percentage of what each tissue was predicted as output. In this study, since there were not many images, I used a pre-trained VGT60 model for the encoder part of unit. I also did data augmentation as image processing. It is possible to artificially increase the appearance and number of images. The implementation result is shown in this slide. The left graph shows the loss, and the right one shows the accuracy. The training data results are drawn as the blue line, and the test results as the green line. We can see as each epoch progresses, the test data loss is getting larger. This suggests the overlearning is occurring. The accuracy score of the test data was 0.72. This is what the actual output image looks like. The green area, the glomerulus, is mostly working well. However, the other part of may be incorrectly predicted. This result from the image also shown in the figures. This table shows for each row which tissues was classified as. For example, 91% of glomeruli are classified correctly, while 6% are classified as interstitium. This glomerular result is considered to be mostly correct. On the other hand, the accuracy for pathologic tubules is bad, especially for tubulitis. Only 22% are correctly classified. Many of these are mistakenly classified interstitium, distal tubules, and other pathologic tubules. Finally, I will discuss the result. I had to try and improve the accuracy of the model. I'd like to try different models and improve the overtraining, especially from the confusion matrix. Pathologic tubules accuracy is not well. To improve this problem, we are thinking of dividing the implementation into phases. In addition, in the medical field, abnormal things never judged as healthy. Currently, I simply create a cloud image from the output of the model. But we need to rethink this evaluation method. For example, I would like to try to indicate the probability of level for each area. This is all from my presentation. Thank you.
Thank you.
Okay, thank you, Miss Miss Amy Haneda, for delivering your work.
Okay, so Q&A time.
Yes, we are. Yes, we can catch some points that she delivered, and this is so sophisticated, and also actually I just learned and heard about that.
Yeah.
But maybe, Mr. Wiga, you want to ask some question?
Yeah, I want ask to Miss Amy.
Yeah, okay, Miss Annie. Mr. Wiga, I have a question for
Okay.
you.
Okay, so may I moderate?
Yeah, thank you.
So,
Miss Annie, where do you take the data? Do you have any coordination with
Please,
certain hospital, or you take it
Miss,
from the public data?
the MC,
Yeah,
Miss Nida.
yes,
bagaimana Pak Imam?
okay.
Okay. Maybe there is the question from the audience.
Yeah, we're still waiting for a question from the audience. So, Miss
Is
Amy
there any
Haneda,
question
maybe you want to
in
answer the question
chat
from Mr.
box?
Wiga. It's about the source of the data.
Maybe there is no question. Mr. Wiga?
Yeah, Mr. Wiga
Okay.
is asking about the source of the data for your research from the organ or pathologic image that you take.
Please unmute, maybe.
Can you see the chat, Miss Haneda?
There is question.
Yes, there is a question.
Yeah, can you catch what I mean? Okay, Mr. Nambo,
Yes,
can
hi.
yeah, Miss Annie is joining us. Joining us.
Yes, still
Yes.
join.
Oh, yeah,
So
yeah. She still be
she is
prepare for.
reading. She is reading the question. Are you on the line?
Yeah, okay.
Question is, there is some international news about criminal matters. There are still errors in arrest of suspects. So I mean, AI utilization in critical field. Is it able to distinguish? In the question, distinguish person's face. For example, the twins.
Oh, ini dia lagi jawab ini ya?
Yeah.
Bagaimana?
I think it's difficult. For example, twins.
Yes, twins and maybe similar
faces.
Yes.
That is hard to human.
I'm sorry, Sensei. Maybe I would like to confirm the questions.
Okay.
Yes, maybe the question is the implementation of deep learning in what is it? In criminal detection or for the CCTV, right? Right now in cities, big cities, there are many CCTV, and then one of the function of the CCTV, like in the road or the what is it? The strategic places, there are many CCTV, and then one of the function is to detecting the face, maybe for the criminal problem. In the criminal problem, and then the what is it? The AI implementation. The AI implementation is still make error because of the what is it? The same detection between one person and the other person, so that make wrong. What is it? Make wrong decision. Make wrong decision. Yeah. Actually, one of the principle in face recognition is by using the catching or detect the sum of what is it? Sum of the points, like Professor Nambo said, by using the eyes and then maybe the ears and the other what is it? Points. So maybe for the next the next or the improving, maybe the problem detection will be reduced, I think. Maybe how about Sensei explanation?
I think still not enough the quality or accuracy of AI. So we use AI in critical field just to support human.
Oh yeah.
But in future, I hope the accuracy is improved and automatically detect, for example, diseases or suspects or and so on. So it is still improving. That's my opinion.
Yeah.
One more question here.
Yes, there is one more question.
Yeah. We still have one more question from YouTube. This is coming from Rizky Fauzi. He asked about AI development. Yeah. The question is, can everyone develop AI with cheap equipment like Atmega microcontroller or other, or which the best programming language to build it?
Yeah. So
yeah, maybe this is about the technical.
I think, for example, in Japan, just the farmer developed the distinguished quality of their products, cucumber. The straight cucumber is good, but bended cucumber is bad. So farmer made the system to detect how straight their products, just as an individual one. So he used the very cheap microcomputer, for example, Raspberry Pi or and so on. So I think it is available to develop a small AI system by individuals with the cheap equipment. Yes. And another question, which is the best programming language? It's difficult. Nowadays, I recommend Python, but in future, I'm not sure. Yes.
Yeah. Okay.
That is my answer.
Okay, thank you, Prof. Nambo. Maybe another question from the participants or audience? Sudah cukup. Yeah, okay. I think this is the end of the session of question and answer for the speaker students from Kanazawa University. Thank you for joining this event, Mr. Hidetaka Nambo, and also the two students, Mr. Nakata and Miss Hemi Miss
Haneda.
Emmy
Haneda.
Emmy Haneda. Okay, thank you. I hope we can enhance our knowledge taken from your presentation. And thank you for sharing your knowledge. We hope that we can apply it in our further research or maybe our education. Thank you very much for sharing. And next week, we still have one meeting. And also, Mr. Rambo, yeah, we still have one meeting for the next week. So don't miss it and still keeping with us. Okay, and thank you for Mr. Imam also for joining us here. And also thank you for all the participants here and the audience here. And maybe you can give some questions if you want to ask. Just feel free to ask and write it on the chat room, maybe on the next week. Okay? So before we end up this session, we would like to take a photo. Please, for the audience, turning on your camera so that we can see your picture. Audiens dari Indonesia, silahkan dinyalakan kameranya karena sesaat lagi kita akan melakukan foto bersama. Sudah nyala? Sudah nyala semua? Belum. Oke. 1, 2, 3. Next slide, please. 1, 2, 3. And then next. Next slide, please. Prepare for yourself. 1, 2, 3. Okay. That's the last. Okay, enough. Thank you, Mr. Hireda Kanambo, and also the students from Kanazawa University, and also Mr. Imam once more. Thank you for joining us, and I hope you still stand by us for the next weeks.
Thank you.
And also thank you, Mr. Wiga, for accompanying me here today so that I wouldn't be alone. Yeah, okay, thank you, and see you next week.
Bye.
Arigatou gozaimashita.